Good afternoon, children. All of you welcome to this new session. In our previous class, we started a new chapter named Materials, Metals and Non-Metals. And we have learned the physical properties of metals and non-metals. Did you remember that points? Okay, then can you see what are the physical properties of metals? Yes, they are malleable in nature. Also, they are ductile. It's sonorous. Also, it is very good conductors of heat and electricity. And also, it is luster in nature. That is, it's very shiny in appearance. Also, these are the physical properties of metals. Then, today, we will be learning about the chemical properties of metals and non-metals. In our previous class, I mentioned about these chemical properties of metals and non-metals. And that include the reaction with water, reaction with oxygen, reaction with acids, etc. So first, we can look the reaction of metals with oxygen. Okay? You are very familiar with these pictures in your daily life, isn't it? Okay, you are very familiar with the rusting of iron. Then, can you see how this happens? How this rusting of iron happens? Mainly, it is due to the reaction of this iron with the oxygen and also the moisture content in our surrounding. Okay, the iron react with oxygen and also the moisture content in our surrounding and forms iron oxide. Like this, all metals react with the oxygen. All metals react with this oxygen and form metal oxide. Okay, all metals react with this oxygen and form metal oxide. The rest is an example for metal oxide, that is iron oxide. Rest is the iron oxide. So, to understand more about this and also to identify the nature of metal oxide, we know that the metal react with oxygen and form metallic oxide. Okay? To understand the nature of this metallic oxide, to identify the nature, that means whether it is an acid or base. Okay? So understanding that, we can see an activity. Okay? For performing this activity, here we take the oxide of metal. Take magnesium oxide ash. That means if we take some magnesium ribbon and burn in atmosphere, we will get some residue or ash. That is the magnesium oxide. The ash get after burning magnesium ribbon is magnesium oxide ash. And here, take magnesium oxide ash and put it in a test tube. Here, we take the magnesium ribbon ash in a test tube. Okay? Because we know that magnesium is an example for metal. And magnesium oxide is metal oxide. To test the nature of metallic oxide, here we take magnesium oxide. Okay? dissolve the magnesium ash using some small amount of water. Okay. After dissolving the magnesium oxide solution in water, we take few drops of dissolved magnesium oxide in two, which one? Litmus papers. Blue litmus paper and red litmus paper. We add few drops of this solution into blue litmus paper and red litmus paper. What is the result? Yes, we can see the result here. That is, there is no color change in blue litmus paper, but the color of red litmus paper changed into blue. That means if there is a color change in red litmus to blue, that means that solution is basic in nature. Here, the red litmus turns blue. It means the magnesium oxide is basic in nature. Okay. We know that when a metal reacts with oxygen, metal oxide forms. And also the magnesium react with oxygen and form magnesium oxide. Likewise, when iron react with oxygen and also it react with water, then therefore iron oxide plus iron hydroxide. When iron react with oxygen and water, they form iron oxide and iron hydroxide. And we see that the nature of magnesium oxide. We know that the nature of magnesium oxide or oxide of magnesium is basic in nature because we saw a color change in red litmus paper. The red litmus paper changed into blue. That means that is basic in nature. So, magnesium oxide is basic in nature. And also we know that the magnesium is an example for which one? Metal or non-metal? Yes, magnesium is an example for metal. So, in general, we can say that metallic oxides are basic in nature. Metallic oxides are basic in nature. We know that when a metal reacts with the oxygen, we get metal oxide or metallic oxide. And that metallic oxides are basic in nature. Okay? Is it clear? Okay. Then we can look what happens when a non-metal reacts with the oxygen. When a non-metal reacts with the oxygen. Okay.
Reaction of nonmetals with oxygen. Place a small piece of phosphorus on a china dish. Burn the phosphorus.
Here we take some amount of phosphorus. And phosphorus is an example for non-metal. That is, phosphorus is a non-metal. So, for understanding the reaction of non-metal with oxygen, we take some amount of phosphorus and reacting it with oxygen.
With the help of a glowing splinter. Cover it with an inverted gas jar. You will observe
Here we put some amount of phosphorus in each china dish. Here we can see that some white fumes are appearing. So for collecting that white fumes, we place a gas jar. Okay?
that the gas jar gets filled with white fumes. Make the gas jar upright and pour some water into it and shake well.
Here we collected that fumes in gas jar and added some water to the gas and dissolved the gas in that water.
The white fumes dissolve in water. Now put a few drops of blue litmus solution into it.
And here we are adding which litmus solution? Blue litmus solution into this solution. Okay?
The color of the litmus changes to red. It shows that
Yes. Here, how is the color change? The blue color changed into red. Here, oxide of phosphorus is acidic in nature because the blue litmus paper changed into red.
the oxide of phosphorus is acidic in nature.
Watch this experiment one more time.
Reaction of nonmetals with oxygen. Place a small piece of phosphorus on a china dish. Burn the phosphorus with the help of a glowing splinter. Cover it with an inverted gas jar. You will observe that the gas jar gets filled with white fumes. Make the gas jar upright and pour some water into it and shake well. The white fumes dissolve in water. Now put a few drops of blue litmus solution into it. The color of the litmus changes to red. It shows that the oxide of phosphorus is acidic in nature.
Yes. Here we take some amount of phosphorus and we collected the fumes coming. That is the oxide of phosphorus. And we dissolved that oxide of phosphorus in water and added blue litmus solution. At that time, the blue litmus solution changed into red in color. If there is a color change from blue to red, that means that substance is acidic in nature. So we can understand that the oxide of phosphorus is acidic in nature. Okay. Also, here we are taking another non-metal, that is sulfur. Sulfur is also an example for non-metal. Sulfur is also an example for non-metal. And also we know that when sulfur react with oxygen, there also sulfur dioxide gas is formed. Okay, when sulfur react with oxygen, sulfur dioxide gas is formed. And also like we done in that experiment, when sulfur dioxide is dissolved in water, okay, sulfurous acid is formed. All of you listen, in this equation we know that when sulfur react with oxygen, sulfur dioxide is formed. Sulfur dioxide. And like in that experiment, we added some amount of water in the fumes. And the fume is sulfur dioxide. Okay. And we added water. Okay. Then we check the pH or the nature of that solution. Okay. We saw a color change from blue to red. That means that will be a acid. That is acidic in nature. So here sulfur dioxide plus water gives sulfurous acid. Which one? Sulfurous acid. That is due to this there is a color change from blue to red. That means that substance is acidic in nature. Here sulfur dioxide plus water gives sulfurous acid. And the sulfurous acid turns the blue litmus paper into red. Okay? And saying generally, oxides of non-metals are acidic in nature. Here we take the non-metal sulfur. The sulfur is an example for non-metal. And when the sulfur reacts with oxygen, sulfur dioxide gas is formed. And we checked the nature of that sulfur dioxide. And we see a color change from blue to red. That means that sulfur dioxide is in which nature? Acidic in nature. And also in generally all oxides of non-metals are acidic in nature. Okay. Then there is a table in which metals and non-metals in acids and bases. We know that calcium hydroxide. The calcium hydroxide, in this calcium hydroxide is an example for base. Then which is the metal present in this base? Which is calcium. Okay. Then second one is sodium hydroxide. Then can you see the metal present in this sodium hydroxide? Which will be the metal present in this sodium hydroxide? Yes, it's simple. It is sodium. Then the third one, potassium hydroxide. Then which is the metal present in potassium hydroxide? It is potassium. Fourth one, copper hydroxide. The second part of all the base is hydroxide. It's very simple you to remember. Copper hydroxide, the calcium hydroxide, it's a base. Sodium hydroxide, it's a base. Potassium hydroxide, base. Then copper hydroxide. Then which is the metal present in copper hydroxide? It's copper. Last, magnesium hydroxide. Which is the metal? Magnesium. It's a table present in your textbook. So, all of you fill that table after this class. Okay. We know that sulfuric acid. It's an acid. Which is a non-metal present in this sulfuric acid? Sulfur. It's a non-metal, sulfur. Then carbonic acid. Which is the non-metal present in this carbonic acid? Simple, carbon. Then name HCl. What is HCl? Hydrochloric acid. HCl is hydrochloric acid. Which is the non-metal present in hydrochloric acid? Simple, it's chlorine. Then nitric acid. Which one? Nitrogen. Last, acetic acid. Which is a non-metal present in acetic acid? It's carbon. Okay? Is it clear? Okay. Next, we can look the reaction of metal with water. Okay? Let us see how metals and non-metals react with water. First, sodium. We know that sodium is an example for metal. And sodium metal is very reactive. It's very reactive. It reacts vigorously with oxygen and in water. A lot of heat is generated in this reaction. Okay. So, therefore, we stored this sodium in kerosene. The sodium is stored in kerosene. Okay. Then, to understand the reaction of sodium in water, we can see an activity. Here we are going to put a piece of sodium metal in water. You observe that the sodium reacts vigorously with water, isn't it? And a lot of heat is generated and it burns. And we know that sodium is a metal, but it reacts vigorously with water. But some other metals do not do so. So we can see the reaction of metals with water in a generalized way. Okay. And sodium is an example for metal and it reacts vigorously with water. But some other metals do not do so. So for example, we know that iron. Iron is a metal, but it reacts very slowly with air and water. Okay. So there is no generalization in the case of the reaction of metals with the water. And next one is reaction of non-metal with the water. Generally, non-metals do not react with water. Generally, the non-metals do not react with the water, though they may be very reactive in air. What is meant by that? That means some non-metals do not react with water, but that will react vigorously with air. That means we can store that type of non-metals in air. And for example, phosphorus. Phosphorus is very reactive non-metal. Phosphorus is an example for non-metal and it is very reactive. It catches fire if exposed to air. That means if we store phosphorus in air, it will catch fire. So we can't store phosphorus in air. So to prevent that, the contact of phosphorus with atmospheric oxygen, the phosphorus is stored in water. We know that phosphorus is an example for non-metal and it is stored in water because that will catch fire if we store that in open air. Okay, that is all about the reaction of metals with water and reaction of non-metals with the water. So in today's class, we have discussed about the reaction of metals with oxygen and reaction of metals with the which one? Yeah, water. And reaction of non-metals with oxygen and reaction of non-metals with the water. We know that when a metal reacts with the oxygen, metallic oxide is formed. And all the metallic oxides are basic in nature. And we know that the non-metals react with oxygen and form metallic oxide. For example, sulfur. Sulfur react with oxygen and form sulfur dioxide. And what about the nature of non-metallic oxide? Non-metallic oxides are acidic in nature. Okay. Then we learned about the reaction of metals with water. There is no generalization in the case of reaction of metals with the water because we sodium is a metal but it react vigorously with water, so we store that in which one, kerosene. But also we know that iron is an example for metal but it react very slowly with water, so there is no generalization in the case of which one, reaction of metals with the water. And in the case of reaction of non-metals with water, generally the non-metals do not react with the water. So some non-metals are kept in water. For example, phosphorus. Phosphorus is highly reactive in air and it catches fire when we store in air. So we store that phosphorus in water because that is non-reactive in water. Okay. All of you read the textbook thoroughly and also don't forget to fill that table 4.1, 4.4. Okay. Then thank you. Have a nice day.